exactly the same as the other value. And so for that, we have what's called the identity operator. It does two things. It checks to make sure that the two values are of the same type, and then it checks if those two values have the same value. And the identity operator is three equal signs. So more often than not, whenever you want to compare to see if one value is equal to another value, you want to use this identity operator. So in the case of our condition, this will return false because the two operands are not identical. The string is not a number, therefore it's not even going to check the value, it's going to return false. But we do have the non-identity operator, which is an exclamation point followed by two equal signs. And this will return true because these two values are not identical. We have a string and a number. And it doesn't even have to be two different types of values. If we have a number 6 and a number 7 and we use the non-identity operator, this will return true because they do not have the same value, even though they are of the same type. Now, instead of looking at numbers, let's look at strings. So let's have a string that says hello, and then let's use the identity operator. And then let's have another string that says hello but has a capital H. These two values are different. Even though they have the same word inside of the string, they are two completely different strings because one has a capital H while the other has a lowercase h. But if we do change the uppercase to a lower, then this will return true because these two strings are identical. And really, it's not a case of identity. It's just a case of equality. This code would return true because hello with a lowercase h is the same as hello with a lowercase h. But changing one of these, even though we're not using the identity operator, this would return false because these two strings are completely different because of the uppercase h. So we've talked about case sensitivity before. All of our identifiers for our variables and our functions need to be case sensitive, and the same is true with our strings. If we want strings to be equal to one another, then they need to have the same casing. We have a few other conditional operators that we will look at in a few minutes. They're called the logical operators. But before we look at those, I want to show you how we make decisions in our code. We do so using an if statement. It uses the if keyword followed by a set of parentheses. And then inside of these parentheses, we put our condition. So the idea of the if statement is, if our condition is true, then we want to execute some code. And the code that we want to execute is in between these curly braces. So we have if followed by our condition and then a set of curly braces. And the code that we have inside of the curly braces, it can be one statement or it can be multiple statements. It really doesn't matter. But whatever code we have listed in between of these curly braces is going to execute when this condition is true. So right now the condition will return true because 5 is less than 6. So let's alert 5 is less than 6. And then after the if statement executes, normal code execution begins. So let's put something outside of the if statement. Let's say this is outside of the if statement. So whenever we run this in a page, the if statement will execute first. We will see an alert message that says 5 is less than 6, and then we will see another alert saying that this is outside of the if statement. So let's run this within the browser. 5 is less than 6. This is outside of the if statement. Well, what happens if we want to execute code if this condition is false? Because as it is right now, the code that we have written isn't going to do that. This code is going to execute regardless if this condition is true or false. So, for example, let's switch this sign to a greater than, and then let's run it in the browser again. We're not going to see that alert saying that 5 is less than 6 because the condition is false. So we're just going to see this is outside of the if statement. So the code outside of the if statement will execute regardless if this condition is true or false. But there are times when we want to execute code if the condition is false, and we use the else statement to do that. And it's a lot like the if statement, except we don't have a condition. It's just if a condition is true, then execute this code. If not, then execute whatever we specify on line 6. So let's alert, this is in the else block. So let's go back to the browser, refresh, and we'll see this is in the else block. And then we will see this is outside of the if statement. Let's look at another example. Let's assign a value of hello, all lowercase, to foo. And then let's compare this value to other string values. So let's do hello with a capital H, and let's alert hello. And then let's perform similar comparisons. Let's do 2 more, so we have 3. Go ahead and paste those. Let's do this one all lowercase. So this comparison is going to return true. And then let's do one with a capital O. Paste that in. So let's first execute this code and then we'll talk about it. We get hello in all lowercase, and then we get this is outside of the if statement. So whenever the browser executes this code, it's first going to evaluate this condition. This is going to return false, so line 5 never executes. Then it's going to evaluate this condition. This will return true, so line 11 executes. Then it will evaluate the final condition. Foo is equal to hello with a capital O. That is false, so line 17 will never execute. And I know that that's rather obvious, but I want to point out that this is inefficient code because we have to evaluate each of these conditions regardless of finding a true condition here. So as far as efficiency is concerned, once we find this condition, we shouldn't be performing this other condition because we've found a match. So instead of using if, and then if, we can use something called an if, followed by an else if, followed by yet another else if. So the idea is kind of the same as the if and the else, except that we are performing another comparison. So whenever this condition is evaluated, this is going to return false. So once again, line 5 will not execute. But then with this else if, this comparison is going to be evaluated. This is going to return true, so line 9 is going to execute. But since this returns true, there's no need to perform this else if comparison. So whenever we execute the code on line 9, this whole if, else if is going to exit, and then we execute whatever is on line 17. So we've made our code a little bit more efficient because now we're only comparing the values that we need to compare. So if we were to put this comparison with all lowercase letters at the top, then that one condition will be evaluated and then none of the other conditions will be. So just to show you, let's run this in our code in our browser. We're going to get the same results as we got before. But we can also add an else statement at the end of this so that if neither of these conditions return true, then we can say no match was found. So let's go ahead and change this to have a capital L. And if we run this within the browser again, we will see that no match was found because each of these if and then else if conditions were evaluated. All of them returned false, so then we finally went to this else block. So that's how we make decisions in our code. We use the if statement to test a condition. If that condition is true, then of course we execute the code within that if statement. If that condition is false, then we have the else statement to execute code. Or if we want to test another condition, if our first condition returns false, then we can use the else if statement to test another condition. So now let's look at logical operators. Before we do that, I'm going to add another variable called bar, give it a value of 5, and let's say that we need to execute some code based upon if foo is equal to hello and if bar is less than 6. Well, if we try to execute this code, we are actually going to get an error. So let's go to the browser, refresh, nothing's happening. But if we look at the JavaScript console, we will see that we get an uncaught syntax error, unexpected identifier on line 4. So if we look at line 4, it's this bar identifier that it's talking about. We have a comparison, foo equals hello, and then we have another comparison, bar is less than 6. But this is an invalid syntax because there's something that should go in between these two comparisons. And this is where the logical operators come in. Logical operators work with Boolean values, and conditions evaluate to Boolean values. So the logical operators allow us to combine multiple smaller conditions into larger, more complex conditions. The first logical operator we'll look at is the logical and I'm going to type these out because this can get a little confusing. And if you're going to type the text version of the logical and operator, then you would want to do that in all uppercase. But in code, the logical and operator is 2 ampersands. It's not 1 ampersand, that's actually the bitwise and, which we're not going to get into bitwise operators at all. So the logical and is 2 ampersands, and it's a lot like the word and in the English language. So let's say, do you like cake and pie? Well, you have multiple answers to this question. If you like cake and you like pie, then the answer is yes. If you like cake but you don't like pie, then the answer is no. If you like pie but you don't like cake, then the answer is no. And then naturally, if you don't like cake and if you don't like pie, then the answer would be no as well. So as far as the logical and operator, if we have true and true, then the result of this logical operation is true. If we have true and false, then the result is false. If false and true, then that is also false. And if false and false, then that is false as well. So if we want to use the logical and operator in this code, which we do because we want to check if foo is equal to hello, all lowercase, and bar is less than 6, then we would want the logical and operator. So whenever we run this code, we will get the value of true within our little alert box, and let's comment out this second alert window. Okay, so that's the logical and operator. The second logical operator is logical or. Once again, all uppercase. And in code, the operator is 2 pipes, and it is not 1 pipe, that is the bitwise or. So you want to use the double pipe for the logical or. The logical or is like the word or in the English language. So do you like cake or pie? There are different answers, obviously, to this question. If you like cake and if you like pie, then the answer is yes. If you like cake but you don't like pie, the question is still yes because it's an or question. Do you like cake or pie? Yes. So if you like pie but you don't like cake, that once again is yes. But if you don't like pie or you don't like cake, then that is no. So it's a different result set than the logical and operator. So if we have true and true, then the result of the logical or operation is true. If we have true and false, then the result is true because it's an or question. Once again, if one of the operands is true, then the logical or is true, and I'm saying logical and here. Why didn't you tell me? Okay, so let's do that. So if we have false or true, that is true. And then if we have false or false, then that is false. So if we change this logical and to logical or, as it is right now, this overall condition is going to return true because both of these smaller conditions return true. Even if we change one to be false, Foo is not equal to hello. Well, that's obviously false because foo does equal hello, but we have this other condition that is still true. So if we were to run this within the browser, we would see the alert box. So in order to not see the alert box, we would have to make both of these conditions return false. So by changing the sign from less than to greater than, that is going to return false for that condition, which will mean that we will not see our alert window anymore. The last logical operator is logical not. And it's very simple. It just has an exclamation point. It's not two, by the way, it's just one exclamation point. And unlike the logical and logical ors, you use the logical not on only one Boolean value. And what it does is it switches the value. So not true results in false, not false results in true. And you might think, well, how do we use that? Well, let's get rid of this second condition because we don't need it. And let's say that we want to reverse the result of this condition because as it is right now, this is returning false. Foo does equal hello, but naturally we could just change the operator to the identity, but that doesn't help us with this particular demonstration. So we use the logical not operator before the Boolean value. So we want to stick it at the beginning of our condition, but we haven't quite done what we wanted to do. We are saying not foo is not equal to hello. That really doesn't make a whole lot of sense. Actually, it does, but we'll get to that in a moment. So instead, we want to surround the condition with parentheses because just like the mathematical operations where we can change the precedence based upon parentheses, we can specify parentheses around a condition in order for that condition to be executed first. So now that foo is not equal to hello is executed first, this is going to return false. And then we use the logical not operator to reverse that false to true. So if we run this code, we will see our alert window once again. And why didn't we? Because I didn't save it. That's always good. So refresh, and there we have true. Logical and illogical or allow us to group multiple conditions into a larger condition so that we can compare multiple values together. And then the logical not allows us to switch the result of a condition or multiple conditions. There's just one more thing that I want to show you and then I'll let you go. I know we're running a little bit later than normal and I apologize, but this is very important. So far we've been talking about just pure true and false values, but JavaScript is a little unique in that it has something called truthy and falsy values. The idea is they are not true or false. They are actually values of other data types, but they are treated as true and false. So they're not true and false. They are truthy and falsy. So let's look at the truthy and falsy values of other data types because it does come in handy to use other data types as inside of your conditions. So we'll first look at numbers. We'll use 0 as our condition, and we'll just alert a message. 0 is a falsy value, so if we try to run this, we aren't going to see our alert window. But if we change it from 0 to any other number, it doesn't matter what number it is, as long as it's not 0, we will see our alert window. So as far as numbers are concerned, 0 is falsy, and any other number is truthy. So strings. The empty string is a falsy value. But if we even add just a single character, then this string is now truthy. So if we refresh, we see our alert window. Arrays are truthy, as are objects. There we go. And we don't have the equivalent of falsy for those. Well, actually we do. We have talked about undefined before. In that whenever you declare a variable, but you don't give it a value, it's said to have a value of undefined. So if we were to use foo as our condition, we would not get anything whenever we refresh the page. And that's because foo is undefined. We can even use the undefined literal value, which I discourage people from using, and by the way, that's not working. I discourage people from using undefined because it's not protected. You can actually assign a value to undefined and change its value. So as it is right now, it's not very reliable. But in a future version of JavaScript, then undefined will be protected and you will not be able to change its value. There's one other value that is called null. This is a falsy value as well, and null is a null object. If you were going to use the type of operator on null, and let's go ahead and do that, alert type of null, we would see object because null is a null object, but it is a falsy value. So you could use the null literal value if you wanted, or you could assign it to a variable and then use that as the condition, and we don't get the alert box that says hi. So anyway, that is going to wrap us up for today. What did we talk about? We talked a lot. We talked about conditions and how we use conditions to make decisions in our code. And we also looked at how we can make decisions using the if, else, and else if statements. We also looked at truthy and falsy values as well. So tomorrow we are going to look at loops, which allow us to repeat code over and over again, and we do so based upon conditions. The next lesson is going to build upon what we talked about today. So have a great one. I will see you next time. Welcome back. This is day 2 of JavaScript Fundamentals, and before we get started, I want to prepare you that I'm going to throw a lot of terminology at you today. So if you're new to programming, I recommend that you write down these terms and their definitions because they're not unique to JavaScript, but they are unique to the programming industry in general. So today we're going to talk about data. And the reason being because whenever we write software, that software is going to work with data in some way, shape, or form. For example, let's just look at the code that we wrote in day 1. We call the alert function, which tells the browser to pop up a new little window to display a message. But it doesn't know what message that we want it to display. We have to provide that data in order so the alert function can do what it's supposed to do. So this textual data that we have passed is data, except that we don't call it textual data in programming. We call this a string, as in it's a string of characters. And every programming language has to provide us what are called data types. They are literally types of data that allow us to work with different types of data in our code. So for example, the JavaScript language gives us a data type called string so that we can work with text in our code. And to create a string, we surround some text with a pair of double quotes. So our string hello world begins with one double quote and ends with a double quote. So anything in between these two quotation marks are part of the same string. But we can also create strings using a single quote instead of a double quote. So we begin the string with a single quote and end the string with a single quote. But we can't mix and match these together. If we begin a string with a double quote, we have to end it with a double quote. And the same is true for single quotes. We can't begin one with a double quote and end it with a single quote. I don't know if you can tell, but the color coding has changed in that all of this is red. So in Web Matrix, strings are denoted by a red color. So everything from hello, JavaScript fundamentals, and then even this single quote and this parenthesis and the semicolon are all considered a string because we haven't ended the string with a double quote because we began it with a double quote. So just keep that in mind. We can't mix and match, but we can create a string in two different ways. Just to be clear on mixing and matching, you cannot begin a string with one type of quote and end it with another type of quote, but you can include a single quote inside of a string that is delimited by double quotes. So let's go to hello world and we can do it's apostrophe s. And this is perfectly fine. We don't have to match this quote at all because it is actually part of the string. And since our string is delimited by double quotes, that's perfectly fine to do. And the reverse is true for single quotes. So if we surround our string with single quotes, we can contain double quotes inside of our string. And once again, we don't have to match them at all. We can have one if we wanted, but with double quotes, you typically have two within the same string. This ability to create strings in different ways, using double quotes or single quotes, is a little unique in the programming world. There are some languages that allow you to do the same thing, but they treat those strings a little bit differently. JavaScript doesn't discriminate. If you create a string with double quotes, it's exactly the same as creating a string with single quotes. So you can choose whichever way you want to go. I personally like double quotes because in other programming languages, double quotes are how you define a string. A lot of PHP developers that pick up JavaScript typically go for the single quote approach. It really doesn't matter just as long as you are consistent. Well, let's take a slight detour and talk about memory and storing values in memory, because most of the time we want to store a value in memory so that we can refer to it later on in our code and refer to it as many times as we want. For example, we have a value, a string value that has hello world in it. And this is a string literal. It literally appears within our code, but there's going to be times when we have values that are not literally in our code. But in this case, we do. But we might also want to store this in memory so that we can refer to this particular value, this string value, without having to retype the string hello world many times. So we do this by creating what's called a variable. It's just a box of memory that we can store stuff in. That's pretty much all it is. And we create a variable by first saying var. Var is a keyword, and a keyword has a special meaning to the JavaScript engine. So whenever it sees var, it knows that we want to create a variable. And you have to put a space after var, just because if you start typing something, then the JavaScript engine doesn't know what this is. It sees var at the beginning, but it's not the keyword var. The keyword var is var followed by a space. After the var keyword, we want to provide a name for our variable because we need some way to refer to it in our code. And variable names can begin with a lowercase letter, an uppercase letter, an underscore, or a $sign. You cannot begin a variable name with a number, but you can use numbers in a variable name. Most of the times you want to begin a variable with a lowercase letter, and I'll tell you why in a moment. But after that first character is written, then you can include numbers. But unless if this means something to you, don't do it. There are times when numbers are going to be something that makes sense for a variable name. But for many purposes, something textual is going to be sufficient because you want to look at a variable name and know what it's supposed to contain so that whenever you're reading, you can say, this variable is supposed to do this, this variable is supposed to keep track of this, and so on and so forth. If you have a cryptic variable name, you're not going to get very far. So I'm going to call this variable, and this is going to be a little confusing and difficult to explain, but I enjoy the challenge. So we have var space, and then the name of the variable, which in this case is variable, and then we can end this statement with a semicolon. Now, JavaScript actually allows us to omit semicolons. It will try to be smart and insert them for us, but do not omit the semicolon. Yes, JavaScript will try to insert a semicolon for you, but sometimes it can do so in the wrong place, which would make your code fail. And the thing is, you wouldn't know that your code is failing because you wouldn't get an error or anything like that, but it would behave in a way that it was not supposed to. So always, always, always use the semicolon at the end of every statement. It's only a character, and it's actually going to be required in a future version of the language. So get your practice in now. Okay, so with this line of code, we have done what's called declared a variable. So we've declared the variable. I've got to change this. This is going to be too confusing to say variable, variable. Okay, so I've changed this to my variable. We have declared a variable called my variable, but we haven't given it a value. In fact, by default, it has a value of undefined. The JavaScript language has a data type called undefined, and it has only one value, undefined. And that kind of makes sense because the value has not been defined yet. But we can define that value by using the variable name followed by an equal sign and then the value that we want this variable to contain. Hello world. So this line, line 2, this statement is called two different things. It's an assignment statement because we have assigned a value to a variable, and it's also called a variable initialization statement. So if line 1 is a variable declaration statement, line 2 is a variable initialization statement. And now that this variable has a value, we can use it just like we would the actual hello world value. So we can pass the variable to the alert function, and we should get the same results that we got in day 1, seeing hello world in an alert box. And just to let you know that this is in fact what's going on, let's add some gibberish to the end of the string, run it again, and there we go. Okay, so this is how we use variables. We declare them, we define them, and then we use them in our code. But there are going to be times when we don't want to do this in 2 lines, the declaration and the initialization. There are going to be times when this is required because we might not have a value for a variable. But most times we know what a variable is going to contain, so we can do the declaration and the initialization all in one statement by just saying var and then the variable name, the equal sign, and then the value that we want to assign to this variable. So if we ran this again in the browser, we would get the same results. Before we move on, I want to talk about our variable name. Now remember I said that we should name our variables according to their purpose or the value that they contain. Well, the purpose of this variable has been for demonstration, but it's not representative of its value. The value hello world, we're not going to change. This variable will always contain hello world. So it would make sense if we named this variable hello world. Now, notice what I've done here. I have uppercased the W in world, and this is a convention of JavaScript called camel casing. Well, camel casing is used in a lot of programming languages, but it's the convention of JavaScript to name your variables in camel case fashion. So what is camel case? Well, if you have multiple words in a name, the first word is all lowercase, and this is why I said you will more than likely begin a variable with a lowercase letter. So the first word is all lowercase, and then any word after that first word begins with an uppercase letter. So W in world is uppercased. If we had other words in this, we would have an uppercase letter for that first letter. So hello world, and then 3 is capitalized, 4 capitalized, 5 capitalized. So it makes it a little bit easier because each word is broken up with a capital letter. So this is camel casing. It is a convention of JavaScript. And as you're reading other people's code, you might run across something that looks like this, using an underscore to separate the different words. Now, there's nothing technically wrong with this code. This is a perfectly valid variable name, but it doesn't follow JavaScript conventions. In fact, this follows PHP conventions. And you will find a lot of code where PHP developers decided to get into JavaScript, but they didn't adopt the JavaScript conventions. And I don't mean to sound haughty or preachy about this. This is just a pet peeve of mine. It doesn't matter what language you're writing in, follow the conventions of that language. So if you're writing in PHP, follow PHP's conventions. If you're writing JavaScript, follow JavaScript conventions. C++, follow C++ conventions. It just makes things easier for you, and it makes it easier for whoever's reading your code. So just follow the conventions of the language. Since this is JavaScript, the convention is camel casing, so use it. And while we're on the subject of casing, it's important to note that JavaScript is case sensitive. So I've written a line of code that assigns a new value to the hello world variable. But there's a slight little difference, as you've probably noticed. This one has an uppercase R, whereas our original hello world variable has a lowercase r. Well, what we end up actually doing is creating a new variable called hello world with an uppercase R. Even though we didn't use the var keyword, we can create a variable like we've done in line 2, but we don't ever want to do that. And I didn't really want to demonstrate this to you because it's considered very bad practice to create a variable without the var keyword. But in the case of this code, that really wasn't our intent. We wanted to assign a new value to our original hello world variable, and because of a typo, we now have a bug in our code because hello world with a lowercase r is a different variable than hello world with an uppercase R. They are two different variables, two different boxes of memory. So as you're writing code, be sure that your casing is correct because you could introduce a bug just from a simple typo. I know, I've been there, and just about every other developer has been there as well. Well, let's look at some of the other data types in JavaScript. One of them is called number, which allows us to work with numeric data within our code. So let's create a new variable called 10, and we will assign it a value of 10. And this is a numeric literal, just like we have string literals. With hello world, we have numeric literals as well. We can have numbers that are whole numbers like 10, or we can have fractional numbers. So I've created another variable called pi to contain 3.14. Now I know that there are other decimal places, but I only know the two. The last data type we'll talk about today is probably the simplest data type that there is. It's called Boolean, Boolean, and it closely resembles that of a bit. A bit can either be on or off. A Boolean value can be either true or it can be false, and those are the two literal values for a Boolean value, true or false. Well, I think this is a good place to stop for today. I've introduced you to the three basic data types in JavaScript: strings, numbers, and Boolean values. Tomorrow we will continue to look at data and how we can work with those numbers and strings. We'll look at how we can convert numbers to strings and strings to numbers. We'll also do some math. We'll join some strings together and all of that wonderful stuff. So get ready for that. Have a good one. Welcome back to JavaScript Fundamentals. This is day 4, and today we're going to talk about functions. Every day thus far we have used functions. We have used the alert function to pop up a window within the browser. We also looked at the parseInt and the parseFloat functions to convert strings to numbers. But you might even still be thinking, well, what really is the purpose of a function? Well, consider the parseInt function. It processes a string to convert it to a number. And let's say that this process takes, 15 lines of code. Every time that we would want to convert a string to a number, we would have to write those 15 lines of code if we didn't have a function to do so. So not only would our code get longer to type, it would also be more error prone because we are, after all, human. We are going to make mistakes as we are typing code. So naturally, the longer our code is, the more likely we are to have an error, a typo, or forgetting to do a certain process, what have you, it would be an error. So this is why functions were created, so that we can reuse pieces of code anytime that we wanted to. And thankfully, we're not limited to just the built-in functions. We can write our own so that we can reuse our own code. For example, I have essentially 6 lines of code. They're broken into 2 sets of 3 lines, but they perform the same operations except for one small difference. The foo variable is starting off with a value of 2, and the bar variable is starting off with the value of 3. Other than that, they're performing the same operations. They're adding this initial value to the number 3, then adding 1 to it, and then multiplying by 8. And let's go ahead and fill this out. So we'll have 5, which is initially assigned to foo, and then we'll add 1 to it, which is 6. then we'll multiply that by 8, which is 48. And by the way, what I'm doing here is taking the value of foo, which at this time is 5. We're adding 1 to 5 and then assigning a new value to foo. So we are modifying the value that foo contains. It no longer contains 5, it contains 6. So in line 4, whenever we execute this line of code, the value of foo is 6, so it's 6 times 8, which is 48, and then that value is assigned to foo. So foo is now 48. And we do the same thing for the bar. We start off with 3 plus 3, which is 6. Then we add 1, which is 7. Then we multiply that by 8, which is 56. So the idea of this code is that we are doing the same set of operations over and over again. We've only done it twice, once for foo and once for bar, but we might want to perform these same operations for other values. So it would make sense to refactor this code into a function. And by refactor, I basically mean rewriting to make it more simplified or more maintainable. So we want to refactor this code into a function so that instead of using 3 lines of code to add 3 and then to add 1 and then to multiply by 8, we could just call the function and do that in 1 line of code. So let's write a function that does this. And to do so, we use a keyword called function. And then we need a name for our function because just like variables, we need some way to refer to this function within our code. And we do need to follow the same naming guidelines as variables. So use camel casing. I'm just going to call this function do something because, well, I don't really have a good name to give it as to what it is that it does. And then we have a set of parentheses after the function name. Now we're going to put something called a parameter here in a moment, but go ahead and just put a set of parentheses, and then we have a set of curly braces. This is marking the beginning and the ending of the function. And that means any code that we put in between the opening curly brace and the closing curly brace is part of the function body. So that code will execute whenever we call the do something function. Now, a moment ago, I mentioned something about parameters. As it is right now, the do something function does not accept any parameters, so it doesn't accept any external data. And that's fine. There are some functions that don't need external data in order to work. But in our case, we do need that because we have an initial value. Foo started with the value of 2. And bar started with the value of 3, so that we need to provide that data to the do something function so that it can perform the necessary operations with that starting value. And to do that, we use a parameter. A parameter is a special variable for a function. It's usable inside of the opening and closing curly brace, but it cannot be used outside of the function that it was defined in. And to define a parameter, all we have to do is type a name in between the opening and closing parentheses. We don't have to use the var keyword. All we have to do is simply type a name. So I'm going to call this param1, and this will allow us to pass data to this do something function so that we can work with it. Now all we need to do is replicate the operations that we want to perform. So instead of using foo or bar, we will use param1 inside of the function. So param1 equals, and param1 is the starting value, so we'll do param1 plus 3, and then we'll do param1 equals param1 plus 1, param1 equals param1 times 8. So we should be able to run the do something function, pass 2 for foo, pass 3 for bar, and get 48 and 56 respectively. So let's go ahead and do that. So do something, we'll pass 3, that should give us 56. And then for foo, do something, pass in 2, that should give us 48. And also let's alert these values. So alert foo, alert bar. I also need an HTML page to run this script, so I will create one right fast. And inside of body, we'll create script, source, This is script.js. And now all we have to do is run it. Now this actually isn't going to work. We are going to get undefined. There we go. And undefined. Well, why are we getting undefined? Because we did accept a value and we did modify it, but the do something function is not returning a value. Yes, it is modifying the value